All right, more limits and algebra. So for number 9, we're going to have a lot of more factoring to do. We're going to have some trinomials to factor. I'm going to use split the middle so that every one of my steps is equal to the step before. So again, I'm going to be really particular about writing my limit notation until I'm ready to evaluate the limit. And 2 times 20 is 40. Two numbers that multiply to 40 and add to 13 are 5 and 8. So I'm going to have 2x squared plus 8x plus 5x plus 20. I'm going to go ahead and keep factoring with my numerator here, and then I'll come back and factor my denominator just so I don't lose my place. So I can take a 2x out of my first two, and I'm left with x plus 4. My second two terms, 5x plus 20, I can divide out of 5, and I'm left with x plus 4, and that's good news because my parentheses should match. Again, every step is equal to the one above. That's very important. And here I have 2x plus 5 times x plus 4. Now, if I was going to forecast, if I'd never done this problem before, I would think like that 2x plus 5, I should probably have that in the denominator so I could cancel it. That's what's causing the issue with the negative 5 halves. All right, in my denominator, 2 times 30 is 60. Two numbers that multiply to 60 and add to 17 are 12 and 5. So 2x squared plus 12x plus 5x plus 30. And I'm going to split it in half. For my first two terms, I can take out a 2x. And I'm left with x plus 6. For my second two terms, 5x plus 30, I can take out a 5. And I'm left with that x plus 6. Good news, my parentheses match. So now I have 2x plus 5, stuff on the outside, times x plus 6. And that's perfect. I can cancel my terms on top and bottom. That's the hole in our function that's creating the difficulty for us. That's the issue with taking the limit. And now that we have that hole canceled, we can evaluate the limit using the rest of the function. So I have x plus 4 over x plus 6. I can drop the limit notation since I'm at the point of evaluating the limit. And you can put that in your calculator or you can do the math there. You should end up with 3/7. All right, one more. The limit as x approaches 1, and this guy's kind of a mess. So when I first looked at this problem and started to try to factor, I noticed 3 times 4 is 12. Two numbers that multiply to 12 and add to 22, not going to work for me. That is not factorable. But then I looked again at what I'm taking the limit approaching. I'm taking the limit as x goes to 1. And when I'm looking at this denominator, I think I'm going to be safe to go ahead and plug that in. So I'm going to try it. So 3 times 1 squared plus 22 times 1 plus 4 all over 5 times 1 squared plus 29 times 1 minus 6. And there's no way I'm going to get a 0 in my denominator, so I'm in great shape. So 22 plus 3 is 25 plus 4 is 29. 5 plus 29 is 34, minus 6 is 20. And that one you can directly check in your calculator, in your table. Just be on the lookout for that. If you start to try to factor and it's not your polynomial or your rational function isn't factorable, don't get too freaked out. see if you can go ahead and just plug in the value. Again, this unit, from my purposes, is really designed to make your work in AP Calculus or the first calculus class that you take easier. So I'm trying to introduce you. I'm not trying to throw super tricky stuff at you. It's all doable. All right, the next video is going to have some limits with complex fractions, because they're my favorite.